Okay, they run the gamut from math profs and physics profs to people who are trying to explain what consciousness is and people who've had insights into consciousness via certain experiences. And those, the latter category, tend to equate consciousness with infinity, whatever that means. And they'll say, well, the ground of reality is both zero and infinity. You and I will both say, I'm unsure what that means. And they'll be like, yes, well, you haven't reached enlightenment yet. Okay, well, I still am not dismissing them. Like, it could be the case. Just because I don't know what it means doesn't mean it's false. How about we explore what you mean when you say that infinity is not real or that you don't like the concept of infinity? Why, psychologically and perhaps practically? And then also, I'm super interested to hear about your new ideas for mathematics and unifying it.
Yeah, so well, I think I have lots of different interests, and so I'm pushing barrels in different directions. So I wouldn't say that I have a grandiose revision of mathematics. I have a way of thinking about mathematics that's more concrete and explicit than say most practitioners, and I think that there's actually a lot to be gained by adopting that more restrictive and more careful and more sort of computationally based approach. And I can see how to push mathematics forward in various directions with that kind of orientation. So we could explore that. I mean, I have my algebraic calculus project. I have a project on rational trigonometry and hyperbolic geometry that's sort of built up from that point of view. And recently I've been talking about solving polynomial equations on one of my channels and sort of outlining a broad new approach to that problem. But there's other things as well. So, I guess I'm more comfortable in dealing with specifics and illustrating things through specific examples. And maybe I'll try to do that in our conversation.
Let's talk about what your gripe is. What is your gripe with infinity? And it's not just the real number. It's not just it's all infinities, even the countable infinities.
Yeah. So I would say that my main reservation probably is in the direction of assuming that one can do an infinite number of things. So I think it's worthwhile to point out, this classical dichotomy between an ongoing infinity and a completed infinity. That was already the subject of thought in Aristotle's day. And the ancient Greeks had a view that an unbounded infinity was like in Euclid. Euclid draws lines, but to him lines can be extended. That's one of his sort of axioms or assumptions. You can always extend a line, but it's not an infinite object to begin with. In fact, at any particular point, it's always a finite object, but it's a finite object that can be extended. In a similar way, we can talk about the natural numbers and we can count, from one up to a certain amount and recognize that we could at least potentially carry on that counting. But at any given time, we are always sort of in a possession with only a range of possible, actual numbers, perhaps constrained by our computers, our memories, or perhaps even more strongly constrained by the size of the universe and perhaps limits that the computational power of the universe imposes on numbers and the possibilities for numbers. So if we have this distinction, then I think what characterizes modern, say, 20th century approaches to infinity is this idea that we can capture the completed infinity, and that we can give that a name, and we can treat it as an object, which is then a prior object that we can then use for further constructions and such. This long-standing respect for the ongoing aspect of infinity, the fact that it goes beyond our view, and at some point we're no longer able to deal with it. That has been lost, and we've replaced that with a kind of an arrogance, in my view, that we can do something which in fact we can't do. So at the heart of my objection, I guess, is this implicit belief that people have that they can do something that they actually demonstrably cannot do. And whether it be working with infinite decimals, working with Dedekind cuts, working with Cauchy sequences of rationals or whatever framework for the real numbers would be, or whether it's involving infinite sets, which are the basis of manifolds or perhaps varieties or topological vector spaces, right? In all these cases, we're kind of assuming that we have this collection of objects that we actually have. It's right in front of us, and that we can then use it to manipulate it in other ways. So I think what we need to do is adopt a more modest and sober position, and recognize what it is that we can and we can't do. We should try to restrict ourselves, in my view, to things that we can do. And a good litmus test for that is, can we get our computer to encode, to embody these notions that we're trying to work with? So it's not a philosophical discussion, particularly where I create pleasant arguments and you create pleasant arguments. It's rather, can the computer support the objects that you're talking about, or that you're wanting to talk about?
I've heard you say before in a few different interviews that it's not real unless you can write it down. Now, I think you're amending that, and what you mean is it's not real unless you can program a computer to do it, because we can write down real analysis with infinities. So I'm assuming when you say write it down, you have a specific meaning of write it down.
Well, actually, I don't know if we really can. I mean, what we can do is, and what we often do is, we write down symbols for things. And we identify in our mind, like we write down this R, this double barred R, and say, okay, there's the real numbers. But of course, that's not really the real numbers. That's just a symbol for it. And in fact, we have symbols for a whole variety of things, including constants, including function values and such, which actually we have a hard time actually really writing down in any meaningful way. And in a completely parallel way, we have a hard time encoding on our computers.
Are you of the mind that underlying reality is something like an algorithmic process that at its core, nature is computational, much like I'm sure you've heard Wolfram talk about?
Yeah, no, I don't have that opinion. I'm not saying that's not a good opinion, and it very well may end up being very close to what's happening. So I think we have to certainly embrace that as a possibility, But I feel as if we're not close enough to the bottom yet to really have a good sense of what's going on. We still have to get these submersibles down further and deeper and in a more thorough way before we can really start making, I think, confident assessments about what's really going on. But I do believe that the algorithmic or computational approach to mathematics is a solid one from a logical point of view. That it gives us a surety that transcends arguments just with phrases and words and English language. It's a kind of a litmus test for whether we're on the right track or not.
When a physics student first encounters infinity as an object, well, let's forget about the real numbers. It is usually from an investigation into spinors, and then Penrose has the Riemann sphere and says, well, okay, the top point of the Riemann sphere, let's call that infinity. And then we give it some algebraic properties that we imagine infinity may have. So if you plus infinity with another constant, it would equal infinity. So I assume you have an objection to that, or maybe you have an objection far before because it's the sphere, which is a continuous entity. So you're like, no, well, I object even far before that level.
I don't object to, the Riemann sphere utilizes stereographic projection to, you think of the equatorial plane as being sort of a copy of the complex numbers, and you can then stereographically project from the North Pole. So you can sort of wrap the plane or the complex numbers onto the sphere, with the exception of this North Pole. And then as you go far out on the complex number plane, then you're approaching this North Pole. So it makes sense to say, okay, well, we have a new point here. We should give it a name. Why don't we call it something? So we could call it Aleph or Zeta or infinity. So I have no problem at all with someone saying, well, let's use this particular symbol, the Leibniz gate symbol, and call it infinity. So that's not an example of of assuming that you can do an infinite number of things, which is ultimately my serious objection, that you're believing that you can do something which you actually can't. In the case of the sphere, you can do the stereographic projection. It's all algebraic. You can make it all algebraic. And so it's completely well-defined, and I have no problems with that. So in classical geometry, for example, in projective geometry uses points at infinity, so-called, in a very important and integral way. And in the 17th and 18th centuries, these points at infinity had something of a mystical aspect. And people didn't really know, what does it mean to have a point at infinity? And it's like the horizon, it's infinitely far away, etc. But in the 19th century, people realized that you could rethink this in terms of affine geometry in one dimension up. So you could understand the projective plane by embedding it in a certain way in three-dimensional affine space. And then that completely demystified the role of infinity. So the infinity then just becomes those points whose third coordinate is 0, as opposed to the other ones which have third coordinate 1. So it becomes completely reasonable, and all the mystery vanishes. So that's I think a good thing to keep in mind. It's whether the crucial thing is, are you assuming that you're able to do an infinite number of things and get a completed result, which you're then using for further constructions.